Okay, welcome to the notes for section 9.1, polar coordinates. Now this is going to be different than what we've been doing with the Cartesian coordinates, which are x and y. And those Cartesian coordinates described where a point was in space relative to the origin. What we're going to be doing is polar coordinates, which we select a point called the pole and a polar axis. The axis is similar to our x-axis with Cartesian coordinates. And the way we designate where that point is in space relative to the pole and the polar axis is the radius, so the distance from the pole to the point, and the angle. So a positive angle would be in the counterclockwise direction, just like on the unit circle. A negative angle would be in the clockwise direction. Okay, so here's what we're going to do is take a look, and we're going to plot these points. Now notice here, R is the first one, your radius, and your radius is always a positive number in that it's a distance. The plus or minus in front of the radius tells us a direction. Our angle, we've already talked about, if it's positive, that's in the counterclockwise direction. If it is a negative angle, it's going to be in the clockwise direction. So on this first one, at 3, 5 pi over 3, I'm going to my pole. The radius is 3, so I go out 3 units. 1, 2, 3. Again, that's the radius of this whole circle. And I want to go around to 5 pi over 3. 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, and 5 pi over 3. So 1, 2, 3. Right here is point A. Point B, the radius is 2, and my theta is negative pi fourths. So I want to come out 2 circles, or the radius of 2, and this time I'm going in the negative direction, so clockwise, and right here will be pi over 4, or negative pi over 4, excuse me, and here is point B. And again, in Cartesian coordinates, we would know the x and y values of each of these, or we could find it using Pythagorean theorem. But in a polar coordinates, notice we've got these concentric circles. Okay, our next one, point C, is at 3, 0. So 3 is the radius. So from the center, or from the pole, 1, 2, 3. Everything on the circle has a radius of 3. And the angle is 0. So that is simply right there. Okay, our last one, we've got a radius of negative 2. Now remember, I've said that the negative tells us a direction. The radius itself is 2, so we've got to get on the circle that's a radius of 2, that's right here. The angle is pi fourths, so that's right here. Now if that had been a positive 2, pi fourths, that would be right here, but it's negative. Now the direction means that instead of going this way, we go past the pole in the opposite direction, so 1, 2. So this is a negative radius, or a direction of negative 2, and that was point D. So again, that's found by pi fourths, the radius of 2, but I need to go in the negative direction, so across the circle, across that pole, to the opposite side by the value of 2. Okay, and there's several ways now to find polar coordinates of a single point. And so if we've got this point, 2, pi fourths, there are numerous ways of indicating that point. And this has to do with coterminal angles. Hopefully we remember those. So for instance, this point C, this is at 1, 2, 3 units, so the radius of 3, and the angle is 0. I could go around the circle again and be at 2 pi. So this would be 3, 2 pi. I could go around another 2 pi. So this would be 3, 4 pi. And I could keep finding coterminal angles right there. So they all have the same terminal side. So it's important to remember there's multiple ways of labeling the exact same point here. So here we're going to take a look at some of these and see how we do them. Okay, so we're taking this point 2, pi fourths, which we had already put on here. So here is my pole, my polar axis, and a radius of 2. So right there is that point, 2, pi fourths. Now we know that these are all coterminal angles. So I could have labeled that same point, go around another pi, So pi fourths plus 2 pi, so pi fourths plus 2 pi gives me 9 pi over 4. So that same point could be labeled as 2 comma 9 pi over 4. Likewise, we could get a coterminal angle by subtracting 2 pi from pi fourths. And if we subtracted 2 pi, we get negative 7 pi fourths. So I could label the same exact point as 2 comma negative 7 pi over fourths. And we have another option here, that this is a little different. What I could do is look at a positive direction of 2. So here's 2 with an angle of 5 pi fourths. But instead of coming in the positive direction, if I said negative 2, it would come across the pole to here. So I have the angle that's on the opposite side and then use a negative radius to indicate that I'm going in the opposite direction. So this point could also have a negative radius, but use the angle that comes over here. I know that sounds a little complicated, but we'll do some practice. So for instance, if I wanted, let's do another one with a negative. This point C, we said was at 1, 2, 3, comma 0. If I want to use a negative radius, I would have to come around that circle with a radius of 3. So this point right here, that would be still a radius of 3. The angle is pi, but I would want to say negative 3 because I don't want it to measure here. I want to go this direction. So point C I could also call as negative 3 pi. That would give me the exact same point. So for every one of these, you can give different values of r or different values of the angle and still be talking about the exact same point on your polar graph. Okay, let's see, how do we actually find these points and find the coterminal angles here? So what we've got this point 3 comma pi 6. So pi 6 is this first angle right here, and we're at 3. So 1, 2, 3. Right there is that point. And what it's asking us to do is find other polar coordinates of this form on the exact same spot, but we have to meet different criteria. So if I want my radius to be greater than 0, and I want theta to be between 2 pi and 4 pi, well, right here it's at 3 comma pi 6. So if I want to be between 2 pi and 4 pi, I'm going to want to add 2 pi to that number. So 3 comma pi 6 plus 2 pi, that's going to give me something that is going to be between 2 pi and 4 pi. And of course you have to get the common denominator. So that's going to be the same as adding 12 pi over 6. So that gives me 13 pi over 6. And I should put it up here with a. So that would give me 3 comma 13 pi over 6. All right, so that meets criteria A with a radius that's positive, and then the theta is between 2 pi and 4 pi. So option B here says I want a negative radius, and I want theta to be between 0 and 2 pi. Okay, so I still want a positive angle, but I want a negative radius, which means the direction is in the opposite. So a positive angle that's opposite here would be right here. So that is 7 pi 6 to get to right here. And then I would go, instead of going this direction, I would go the opposite. So this would be radius of negative 3, excuse me, because I need to go in the opposite direction, and 7 pi over 6. So again, 7 pi over 6 gets me right here. A radius of 3 would put me here, but I want the opposite direction. So I want to go there, which puts me back at that same starting point. Okay, so that's B. C says I want a positive radius, and I want the angle to be between negative 2 pi and 0. So that means I'm going around this direction. So if I'm going this direction, that's negative pi, negative 3 pi over 2. This will be negative 11 pi over 6. So this one is going to be at 3, negative 11 pi over 6. And one last one to try here. For this, I need a negative angle and a negative theta. So I need the angle to be over here. That's going to be negative 3 will be the radius. The angle